Okay, lecture 11. Lecture 11, let's see, we're still doing emoji art. We did drag and drop last time. And today we're going to do gestures, zooming and panning around on our document. And then we're going to add another entirely different MVVM to emoji art. So emoji art is going to have two MVVMs in it. And of course, real apps have many, many MVVMs. So getting to see what one at least has two in it is a step along the road there. So let's talk about gestures and how they work. Of course, gestures are used to get input from the user, and SwiftUI has really powerful mechanisms in it for recognizing common gestures like pinches and drags and things like that. And we call all this gesture recognition multi-touch because you have multiple fingers and they can be on the screen at the same time. SwiftUI internally takes care of recognizing the gestures like, oh, is that a pinch or is that a drag? What's going on with the fingers right there? So you don't actually ever write any code that's looking at a finger and seeing something about it. Swift recognizes the combination of fingers as a gesture. What you have to do is write the code that handles a gesture. What do I do in my app when I get a pinch or a drag or a tap or whatever? And you've already actually done this with on-tap gesture. Tap is the world's simplest gesture, but now we're going to see how to handle much more powerful gestures. To handle a gesture, you're going to start by using the view modifier called gesture on the view inside which the gesture is going to be recognized. And the gesture that you pass as the argument to the gesture view modifier has to be something that implements the gesture protocol. And 99.99% of the time, it's going to be something that Apple has written. One of the gestures Apple has written, drags and pinches and all that. So to create the gesture that you're going to pass to your view modifier there, you're usually going to create a computed var or a function that holds it. It could actually just be a local variable at the top of your view builder if it's a simple one. But usually we put it like this in a computed var. And the computer's var return value is going to be some gesture, because then inside we can put a gesture and we're going to modify our gestures. So creating a gesture feels a little bit like creating a view. There's not really a gesture builder or anything like that, but it is similar in that we have a gesture, like in this case a tap gesture, and then we're going to send functions to it that modify it. And most of the modifications we make are how to handle the gesture. This is a simple tap gesture. It's a double tap actually because it's got a count of 2 there. How do we do something to recognize a gesture? We've attached it to a view. The SwiftUI has realized that inside that view a pinch is happening or a tap is happening or whatever. And so how do we recognize it? Well, it depends a little bit first on whether it's a discrete gesture, like a tap, where it just the tap happens and that's it. There's no other thing going on, or whether it's non-discrete, like a drag or a pinch, where it's happening over time. So the discrete gesture, tap gesture is really the discrete gesture. Long press, I think, can also be treated as a discrete gesture, i.e. long pressed on something, let go, that it happened. And to do something in a discrete gesture, all we do is do this gesture modifier, if you want to call it that, this function, dot on ended. And we give it a closure. We just attach it to the end of our gesture there. And that closure can do whatever we want. That's how we handle discrete gestures. Could not be any easier. And of course, it's so easy that we usually use these built-in things on tap gesture or on long press gesture, which you haven't seen, but you can imagine exists, that just passes that closure onto it. Those things on tap gesture is doing literally what it shows there in the green. It's creating a tap gesture, a dot on ended, and passing the closure in there. So the meat of this, though, is non-discrete gestures. That's what we really have to understand the mechanism for. In these cases, you're not just handling the fact that a pinch happened or a drag happened. You want to be doing something to give the user feedback while it's happening. That's what the infrastructure here is all about. Typical non-discrete gestures, drags, magnification. There's a rotation gesture, which is you put 2 fingers down on your screen and turn it like a knob. And these things are all handled this exact same way. So let's talk about how that works. Here's a non-discrete gesture, drag, And of course, you can still have dot on ended, and you almost certainly would have dot on ended, but there's a little difference. The dot on ended of a drag gesture, that little pink value. You see the value there? So that value is telling you the state of the drag when it ended. And that value depends on what kind of gesture it is. For a drag, it's actually a fairly complicated value. It's a struct that has things in there like where the drag started, how far the drag went, even kind of wacky things of if the user was swiping, where the drag would have ended if it had continued to fly at the rate that it was going across the screen. So drag gestures have a very complicated value. Magnification gesture, which is what you think of as a pinch, super simple value. It's just the scale. Right? If the fingers start here and then move twice as far apart, it's just the number 2. If they start here and move halfway together, it's 0.5. So it's just telling you the scale. That is the entirety of the value. It's a CG float for a magnification gesture. And for a rotation gesture, it's an angle. Right? Remember we saw that type angle that we used in our pi. It's just going to report to you the angle of the rotation. On ended happens, or the drag happened, the pinch happened, whatever, and it ends. Ending means the fingers left the screen. They got lifted off the screen. And you get told via on ended, here's what the state of the world was when it ended. But what about during the gesture? Fingers are moving on the screen. At that time, you get to a chance to update some state. And the state is stored in a special @sign var. It's called an @sign gesture state. Now this is different than @sign state. @sign gesture state, still like @sign state in that it can be any value type you want, int or float or a struct, your own enum, whatever you want. In fact, oftentimes a gesture state is an enum because as a gesture happens on screen, you're going through some sort of state machine. Maybe it's dragging in and out of other areas on the screen and some enum is changing its state from I'm inside to now I'm outside or whatever. It can be anything you want. But this gesture state is kind of interesting because you can only update it while the gesture is happening. When the gesture is not happening, it goes back to its starting value. So you see how I've said @sign gesture state, my gesture state equals starting value? It will always be at that starting value unless the gesture is in flight, actually happening. That's the only time that you can modify this thing. And again, you can set it to anything you want based on what's happening during the gesture. So how do we update this thing in the middle of the gesture? We know that we can update on dot on ended. What about in the middle? Well, we're doing that with another modifier called dot updating. So dot updating, and we're going to talk about all the arguments to it here. And I apologize in advance for this because these arguments are using some technologies I haven't talked to you about. So for now, I'm just going to say, just do what I say and don't worry about why. And then later, when we cover some of this stuff, we'll be able to look back and say, oh, that's why that was like that. But I can't really tell you right now, so just take it on faith. But anyway, you have this updating, and you can see that the updating's argument there is the gesture state, right? It has a $sign in front, but it says my gesture state. And then inside that closure, you get to update your gesture state. And that's the only time you can update your gesture state. It's during this updating thing. No other time, like you can't do it in your on a peer or any other code, only in here. So this gesture state literally is the state during the gesture's flight, and only then. And when all this gesture ends, it's going to go back to its starting value. Now let's talk a little about these funky arguments here. The $sign, you see the $sign in front of my gesture state. Again, I'm not going to talk about that till next week, but just always put it there. A $sign, the name of your @sign gesture state var. The value, of course, is the same value that's in on ended, except for it's the value at that point in the gesture. Right? As you're dragging across the screen, the value is constantly updating. And this updating closure that you provide here that has the value, it's going to get called every time the fingers move, or like in a long press, it actually gets called every once in a while over time. But as the gesture is happening, basically, this value is being updated and your closure keeps getting called over and over. Now, the second variable, very strangely, is your gesture state again. Again, I'm not going to explain why that's there again. It's like, why does that need to be there twice? But it just does. You're always going to have $, your gesture state variable as the argument, and then in your closure, it's essentially passed back to you inside that, so you can modify it inside the closure. It's weird. It's weird. We'll see why later. And then the third argument there, transaction, that has to do with animation. And we're not going to talk about the transaction, but when you're doing gesture handling, you might want to know what's happening in terms of my animation state. What's my animation curve and things like that. And the transaction can give you that information, but that's really advanced animation and gesture. So we're not going to talk about that at all. So this is how you do updating. And the two takeaways here to really understand, one is that inside that updating, you're not updating your model or any of your at-sign state, you're updating your gesture state, only your gesture state. And the second thing is you can only modify your gesture state in here. So it cuts both ways. Now you might say, why do we make this huge separation like this? And I'll be able to show you in the demo what would happen if we didn't have separate state. It definitely won't work. But there is a way to do all this without using this separate state, and that's on changed. Just like you had updating, you can do on change. Now on change gets past the value, but none of that other stuff, and there's no $ gesture state, because in on change, you can actually modify your model or at-sign state. This really only makes sense if your model, right, or your at-sign state of your view is directly tied to where the finger is, like you're doing a drawing app, you see, and as you drag your finger around, the drawing is following, or you're doing drag to select, and as you drag out the rectangle, you're selecting or deselecting things under it. That depends on where the finger is. If you're doing something like we're doing with zoom pinching to zoom or panning around, those things are really relative to where it started. When I start to pan on my emoji art document, I want it to move as far as my finger has moved since I started. In other words, relative. I don't want it to move under the finger somehow. It's just moving relative. Same thing with the zoom. If I pinch down half, it should be half as big as it was when it started. It's surprisingly on changed, you don't use it that much. You would have to have some situation where you wanted to change your model or your at-sign state variables as the thing is happening, which is pretty rare. Here's a summary of how to think about handling these non-discrete gestures, now that you've seen all that. The first thing is you're going to collect all the information that you need to draw differently while the gesture is in motion into an at-sign gesture state. That's what it's for, right? Things that you need to know that are changing while the gesture is happening. That gets put into your gesture state. Sometimes it's the same thing as the value you're getting back, like the pinch. You just need to know the amount of the pinch. That's fine. But you're going to collect it all into a gesture state. Then you're going to add that dot updating on there. And the system is going to be giving you this value over and over to tell you the state of it. And you're going to use that information to update your gesture state. You're going to understand that when the gesture is over, the gesture state will reset back. The gesture state really, it should be at some well-known reset position all the time, except for when you're actually in the gesture. Now you update your gesture state while the fingers are down and moving only. You never update your gesture set again in on up here or anywhere else. And your model and your state is permanently updated in onEnded. That's what you do in onEnded. Update your model or your at-sign state. One way to think about this that sometimes clears it up for people is updating is for the at-sign gesture state, onEnded is for the model and at-sign state. Now your views, of course, are drawing themselves. They have all kinds of view modifiers, opacity, and all these things. Well, the arguments to them are using both the gesture state and the model and your at-sign state, all of those things, to make those decisions. Maybe while it's in the middle of a gesture, it needs to be amplifying the zoom because we're zooming in, right? And so it's doing that, or it needs to add a little extra pan movement during the gesture. So you're using both the gesture state bar and the model state throughout your entire view wherever appropriate. And you know that your gesture state keeps resetting back to this known value when you're not in flight. So we'll see that in the demo. In fact, all of this is best understood when you see it. So let's go add zooming and panning to our emoji art document. And I'm not gonna get back to the slides, so let me just look ahead a little bit after we do the multi-VVMs today. Next week, we're going to talk a little about colors and images and navigation, sheets, popovers, forms, something called @ binding, which is a really important part here, and then probably alerts and error handling, which I originally was thinking I would talk about next week. I'll actually put that off to the week after. All right, so we want to be able to pinch to zoom in and pan with our finger to move around in our document, sort of like this. Got one over here. Here's emoji art. This is a little down the road version of it, but I'm going to pinch. By the way, when you're using the simulator like this, you can pinch by holding down the Option key, and you see I get 2 fingers right there, Option, 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 and then you can drag. So here I'm zooming. See how I'm pinching to zoom? And of course, as I zoom out, I might then want to move it over. So I'm dragging. So dragging and pinching. That's what we're going to be implementing, those 2 things. Now, what gets dragged around and zoomed in on? Well, it's the contents of our document. So that's the background and all the emojis. All of that stuff all gets zoomed. That's what you see in blue here. I'm going to take this stuff and put it in its own var. This is going to be the var of my document contents, and that's the thing I'm going to zoom and pan around on. So I'm just going to cut it out of here, put it down here in a private func document contents, I'm going to call it. And it's a func because I need my geometry in here. I need my geometry kind of everywhere in this stuff because my view coordinate transform between the emoji art and my view always requires the geometry. I always have to know my coordinate system there. And then I'm just going to paste this in here, and this is going to get an error, and I want to see if anybody can tell me what the problem here is. It says here, function declares an opaque return type but has no defined value. Why would it be saying that? This returns some view. How does some view know which view it is? It looks inside here, right? Inside this curly brace. What does it see in here? 2 views, async image and for each. Well, that's not a valid thing. That's 2 views, not 1. This is easily fixed. @ view builder. Turn this little function into an @ view builder function. All of a sudden, it returns 1 view, which is the combination. It's a tuple view of those 2 views. All right, now that I have this document contents, I can put it up here. Document contents in my geometry. Notice I didn't put my white background in there because I don't want my white background to get zoomed in on. It's the background upon which my document lives, right? So that my document is small, I see the white background. So I don't want that. So I have my document contents here. Now I'm going to zoom and pan around on them. First, let's create some @state. Put it down here, I think. Yeah, we'll put it here. @state, private, var, zoom, which is a CG float, which is how much I'm zoomed in on. And let's have it start 1. So I'm zoomed in 1. It's not twice the size, it's not half the size, it's the size. And I'm going to have another one here, @state, private, var. Call this my pan, and it's going to be a CG size .0. And when we talk about offsets in SwiftUI, we use CG sizes, which is fine because do you really want to have another type in addition to CG size? Because it's the same as CG size in that it has a X offset and a Y offset. But you could imagine having a type CG offset that instead of having width and height as its 2 things in the struct, it's like DX and DY or something like that. Now, I like to remind myself when I'm using a CG size as a CG offset by calling it CG offset. And then over in my extensions here, I put a little type alias that says CG offset equals CG size. It's just to remind me, oh yeah, that's right, this is a CG size, but really I'm using it as an offset. So here's my zoom and pan. How do I use my zoom and pan to make my document contents be zoomed and panned? Well, this is incredibly easy. I'm just going to have a scale effect which is my zoom, and I'm going to use something we already know, offset, to do my pan. And that is all I need to do to make zooming and panning working. So scale effect is a view modifier that just takes whatever view you put it on and it scales it by that much. So I'm scaling it by 1 in this case so far. But as we change it, it's going to scale up and down. And same thing, offset offsets it from where it normally should be. Right? That's what we've already seen offset before. So let's see if this works. Let's change our zoom. How about let's make our zoom be 0.5 and just run this and see if it makes it 0.5. It did. We can already tell it did. It doesn't fill the screen. It shrunk in 0.5. We don't even need to go any farther. We know that that's what's happening. How about the offset? Let's make our offset be CG offset width 100, height 100. This is CG offset. Notice it's a type alias, so it works just as well to say CG offset there. I could also say .init, because I did explicitly type this, so we can infer that the init to call there is CG offset to init, which is CG size because of our type alias. See if that works. Yeah, it did, right? Offset 100, 100, and remember, 100 is down. It went over 100 and then down 100 because this is all happening in our iOS upside down system. So it's definitely working. This is great. I already have a mechanism to do this. Now I just somehow need to add gestures that change this zoom and pan. Let's start with zoom. Right, zoom is probably the easier of the two. And I told you that if I wanted to make something have a gesture recognized on it, I just say gesture, a zoom gesture here. I'm going to go down here, a private var zoom gesture, which is some gesture. And I'm going to return what gesture in here. And in this case, it's going to be a magnification gesture. So magnification gesture is that pinching thing. This dot gesture here, notice I put it on the Z stack. So it's going to be recognized anywhere, even outside of my zoomed in document on the white background, whatever, the whole Z stack is going to recognize that this pinch is happening here. And it's important to think about, where do you want the thing to be recognized? For example, in your homework, you're going to add a drag gesture that lets you drag individual emojis. Well, you want that to be attached to the individual emojis, not to the background. That dot gesture, it matters where you put it. You're saying essentially the rectangle in which that gesture, the system's going to recognize, oh yeah, there was a pinch there. Now, in your homework, you're not going to put the pinch on the little emoji because you don't want a tiny little pinch to have to resize it. So you're going to use the pinch you're using on the background and just have it resize all the things in your selection. So this zoom gesture down here, let's start by just putting the dot on ended here. So we're just going to do the dot ended, and it has this thing value in, and we can do whatever we want. And this is going to be when the pinch stops moving and they lift the fingers there. We can go take a look. I'm just going to click on this, option click, and see the value. Its type is magnification gesture dot value. This is a type. It's nested inside magnification gesture. So let's click on it and look at it. And it's just type alias to be a CG float, because that's the only value we have with pinch. Super simple. Now, when we do this for drag, you're going to see this is going to be a struct here. All right. What are we doing in on-ended? So we pinched this thing, and maybe the pinch got twice as big or half as big or whatever. We're just going to change our zoom by that much. We already have this zoom, so let's just say zoom times equals that value. And if this makes it so you understand it any better, I'm not sure it does, but instead of calling this value, maybe we would call it ending pinch scale or something like that, because that's what this is. This is just the ending pinch scale, the pinch scale we had at the end. And that's all we need to do to make this recognize it and pinch it. So let's go back over here. I'm going to hold down this option thing so I get 2 fingers, and then I'm going to drag. It worked. But of course, we're not seeing anything while it's dragging. I drag it around, and then whoop, when I let go, it works. So here I'm going to pinch out, pinch in. So you see how on the on-ended, we've updated our permanent state, which in this case is our @ state. By the way, why is our zoom in an @ state instead of like being in our model or something? Well, because zooming and panning in on the document is not part of an emoji document. It's how we're viewing it. So it's part of the view, but it's only temporary. It's only while we're viewing it, zooming around. So that's perfect to be @ state. So we're almost there. We've got this thing so that it is nicely pinching in the on-ended. Now comes the little bit trickier part. I want to update this thing while I'm pinching. I want it to zoom while I'm pinching. We can do this dot updating thing. So we let's go down here and say @ gesture state private var. I'm going to call this my gesture zoom. This is the zoom that's happening while I'm gesturing. It's a CG float, and I'll have it be 1 by default. And that's what the value is going to go back to every time. So now that I have this gesture state, let's put it in here. Gesture zoom, and then I have to do this wacky thing where I have the value, that's the pinch scale. Then I type my gesture zoom again, and then I have this transaction. And we're not going to use the transaction because we're not doing the animation thing, so I'm just going to underbar that out of there. Remember, underbar in Swift means I don't really care about this. You might think, can I just say the same exact thing here? Zoom here. All right, and just use this value here. We'll call this the in motion pinch scale. Can I just use my in motion pinch scale here when I'm zooming? Forget that gesture zoom thing. Why do I even need that gesture state? Let's see what happens if we do that. Well, it seems here like only the unended is working. Why is this only working on unended? Well, if we go back and look at our code, we'll see that we have a purple error. A purple error is a runtime error. And Xcode is just showing you the line of code that caused this runtime error. So what is this thing? Modifying state during update causes undefined behavior. Inside this updating, you can't modify your @ state or your model, or you'll get this purple thing right here. The whole system is designed to only have gesture state be modified in here. All right, so I switched that there to make it so that only gesture state is modified in here, but I have to use this gesture state in the normal operation of my view somewhere, and the obvious place is right here. This is my gesture zoom. So as I'm zooming, my scale effect is not just the zoom that it normally has when I'm not gesturing, it's that times whatever the gesture is. And I'm not saying zoom equals zoom times this, I'm just saying the scale is zoom times that. So I'm not getting the exponential effect here. That's it. So I've used both the gesture zoom and my normal steady state zoom, if you want to think of it that way, together. Now when I'm not zooming, what's the value of this going to be? 1. So this is going to multiply my zoom times 1, which is exactly what I want. When I'm not gesturing, I want to just use my normal zoom. So let's see this, make sure we don't get any purple and that this works. All right, here we go. And now I'm going to do tiny little movements. You see, I'm doing tiny movements and it's moving tiny. And if I move big movements. So it's tracking how big my movements are. The simplest possible case is zooming because we have such a simple value here, which is just the amount of the pinch. But we're going to do drag also. It's a little more complicated because it's got that struct, but similar kind of mechanism. Just create a new gesture. We got our zoom gesture here. I'm going to create another one called a pan gesture, private var pan gesture, some gesture. And this one is a drag gesture. So drag gesture just means anytime you're dragging your finger across the screen. We're using it for panning. That's why we call it a pan gesture, but it's a drag gesture. And we want both this zoom gesture and the pan gesture to be recognized. Now, it is possible to just go like this, gesture here and pan gesture here. You want to be a little careful doing this. Some gestures will consume the finger movements before you can get to the other one. In fact, this order would probably be bad. If you did this, your pan gestures probably would not work Because the zoom gesture would be, you put one finger down, you start moving, and the zoom gesture is, where's that second finger? I need that second finger. And it's not coming down, so it's not recognizing it. But there's a way to deal with this, which is much better, which is we'll say pan gesture dot simultaneously with zoom gesture. And this tells the system that I want both of these gestures to be recognized at the same time. Again, we're talking about recognition here, just recognizing that they exist. You still, only one of them is going to actually get handled. And in this case, I think what would happen is you start panning, it's going to immediately start thinking you're panning. If you start zooming, it's going to start saying, oh, now you're zooming, and it's going to switch over to the zooming. I think that's how it would do it. I'm not 100% sure. But at least here you're telling it, inside my rectangle, recognize both of these at the same time. There's other kind of arrangements you can have here, like you can have recognize this gesture before this one. So for example, long press and drag. You can say, recognize a long press first, then drag. Don't do the drag unless I get that long press first. In addition to simultaneously with, there's some other ones. You can go look in gesture to see what they are. But now we're recognizing these things. Let's make it so the pan gesture actually does what a pan gesture does. Again, we'll start with the on-ended, because that's where we have to update our model or @sign state. Let's go take a look at this type, the drag gestures value in the documentation. And I told you it was a struct, and here it is. Look at all the things that are in here. Location, that's the location of the finger. There's predicted end translation and end location. That's what I was telling you about, the keeping in mind the velocity of the finger. Time will tell you actually the date stamp in nanoseconds of when this particular value was taken as the finger moves across the screen. And then the one we're interested in is this one, translation. That's how far the finger has moved since it started. That's its offset basically since it started. That's the one that we want. Let's go back in here. Our ended value is just saying our pan plus equals the values translation. Now, it's an interesting line of code. Makes sense, right? Because translation, that's a CG size, CG offset in our world, and we're plus equaling. But you can't actually plus equal CG sizes. CG sizes have a width and a height in them. You'd think you could say plus equals, but you can't. So I added that, plus equals, the reason it works, in my extensions. So I'm going to show you, and I did it because I wanted to show you what it looks like, an operator like that. Plus equals is an operator. How do you do it? You're going to kind of recognize this similar to what we did with the equatable protocol, and we overrode equals equals, right? That static func. So here is plus equals inside CG offset, which is CG size. And it's a static func, just like equals equals was a static func, because of course I can take any two CG sizes and do this. And it's got a left-hand side and a right-hand side, and it adds them. And it's got this in out. Okay, we haven't talked about in out. You probably read about it in your reading. This means that this parameter gets copied back out. When this function ends, that parameter, LHS, gets copied back out. And I specifically say it that way because that's the way it is. It gets copied in at the start, and then you do whatever you do, and then it gets copied out at the end. And that's what I want here, because when I'm doing plus equals, I'm changing the value in place, right? I want whatever the left-hand side is of the plus equals thing, I want it to get the new value. I overrode this operator too, plus, so that I could add two CG offsets together. So this is actually an overridden one, right? Or not overridden, but really invented for CG sizes on the left and right, and it's using another one. Let's go and run. I'll zoom first. Now I'm going to pan. I'm dragging around, dragging, and I let go. And it worked, unended. But we need it to work while it's happening. Exact same thing as we did before. So we're going to have some gesture state. Private var gesture pan. And I'm going to have this be a CG offset. Now it could be, I could have that be the struct that has all the information in there, but I don't need it all. I just really need that translation. So that's the only piece I'm going to do. And I told you that these gesture states can be anything you want. And then down here, I'm going to say dot updating, and I have to put a dollar sign in front of my gesture pan. And then the arguments are the value, and then once again, gesture pan, and we don't want the translation, forget that. So inside here, I can only update my gesture state. I can't update my model or my @ state, or I'll get that purple warning. So let's do that, gesture pan, and my gesture pan equals this values translation, getting that out of the struct. So let's go up here, and in our offset, we're going to have our pan plus our gesture pan, and this plus is going to work also because of my extension. I can just add these CG offsets together. Here we go. Zoom in, pan around. Let's make sure it's actually working with a background. Here's our background. It's really valuable now that we have zooming and panning for this kind of background. It's kind of a weird size background, yeah. All right, so that's pretty good, but this is actually going to cause a major problem. This is really nice, but watch this. So let's put this here now. I want to put, how about an airplane in the sky? Here we go, airplane, hey, up here in the sky. Whoa, the airplane's down here. What? How about a rocket over here? What is that? Why is there anything way down there? Well, because when we drop our emojis, when we do our translation from one coordinate system to the other, we don't take into effect that we might be zoomed and panned. We're going to have to put a little math in to make it so that we adjust for that. Luckily, I knew this was going to happen, so I put the conversion from one coordinate system to another in this nice emoji position. You remember this function that we wrote? So we just need to tinker with this a little bit to get this to work. It's actually quite easy because what's going on here is our center keeps getting moved when we pan, and then the distance we are from the middle keeps getting zoomed out, so we need to de-zoom it. So we're just going to say center.x right here minus our pan width. That's the offset of our pan width here. And same thing here, our center.y minus our pan height. Then we're going to take this value that we just calculated, and we got to de-zoom it. So we're going to take it and just divide it by the zoom. Same thing here. Divide this by the zoom. And what do we got here? We got to put this inside this int conversion here. You can convince yourself later that that's right, and we'll also convince ourselves by going and running. See if it works. Here we go. Just for fun, let's go ahead and bring back our background, a little different background this time. And we'll zoom in, we'll zoom way in. And again, let's do the airplane trick. Their airplane up in the sky. Oh no, still doesn't seem like it worked. Well, actually it kind of did. There's the airplane. Ooh, it's a very small airplane up there, but it's in the right place. It dropped it where I dropped it, but the size is wrong. Well, we also need to do an adjustment on the size we make the thing in there based on the zoom. When we're dropping into a highly zoomed thing, we need to make the thing much bigger so that it matches that zoom. That's easy too. That's right here where we're adding emoji. Instead of using the palette emoji size, we'll also divide this by the zoom. Let's try that. Zoom in here. And we'll get a rocket this time. Put it up here. That's the right size. Cool. Now, when you add your gestures, you're going to be able to resize the emojis. So this is really not that big a deal, but it's kind of nice right now to be able to control the size of our emojis relatively by zooming and panning on the background. So hopefully now you know enough to make it happen. I'll just tell you that your homework is mostly about figuring out where to put your gesture variables and your model and your state in all your view modifiers, right? You have all these view modifiers and you're trying to figure out which ones go where. And there's a little bit in your homework too about you have to manage selection. I got to be able to select the bike so that I can zoom in on it and move it. A minor thing. We're going to go on now to the second topic, which is second MVVM. Anyone have any questions about gestures before we do that? All right. What is the second MVVM we're going to do? Well, I actually am going to show you over here, way over here. Here's a version of emoji art we're going to build. You can see down here at the bottom, and I'm actually going to move it out of the way. Look at my emoji list right here. It actually has a little name now. Sports. These are my sports emojis. And look at this little palette. If I tap it, oh, I get to see other palettes. So I'm going to have multiple palettes with different kinds of emojis in there. When I tap on that little thing, it's going to cycle through them. Not only that, if I press and hold on it, then I can add a new one. In this case, I added math. Click around. And if I don't like animals, then I can delete the animals out of there. And now they're not even in the list. So this is what we're going to build. And this whole world here is going to be its own MVVM. So let's start with the model of this. What is the model of that? And the core of the model of that is one palette, one named set of emojis. That is the core. And I'm going to call that struct a palette. It's like an artist palette, right? We're doing emoji art, but instead of paint, we have emojis. So let's go create in our model a palette. Palette, I'm going to call it. Make sure I put it in the right places. There we go. Create. There it is. Maybe we'll put these down towards the bottom. Here's our model. Of course, it is a model, so it's not in the UI. It's not going to import Swift UI. It's a simple struct called palette. And what's in there? Well, each one of those little things had a name, like vehicles or math or something like that. So we're going to have var name string. And what else did it have? Well, it had a bunch of emojis. We'll go ahead and store all those emojis as a string. We already know we have that scrolling thing that takes a string of emojis and scrolls on it for us. So we're going to reuse that. And now we know that those palettes are going to be in the UI. They need to be identifiable. We all know by now when we're cycling through things, they need to be identifiable. So let's just make this thing identifiable right off the bat here. Colon identifiable. And a good question here is what, we don't even need a var, what should its ID be? And we've seen different strategies for doing the ID. In set, I had the ID of a set card be all the symbols and colors on the card because that uniquely identified the card really well. In memorize, we put a little string, right, that was semantically, pair 1A and 1B. Some of you in your set, you just put 1 through 81, a number on there, an integer or whatever. That's what we do in emoji art for its emojis. We just have an integer and we just keep incrementing it every time we add one. What I'm going to use here is an interesting one, which is I'm going to set it equal to a UUID. UUID is a little struct that generates a unique ID. It's, big, 16 bytes or something of just randomly generated, not randomly, but uniquely generated stuff. And when do you use a UUID as your identifiable ID? Well, when you have a fairly small number of things, like it would make no sense in emoji art to do that. We could have an emoji art, hundreds or thousands of it, and then we could have hundreds of documents with millions. We wouldn't want to be generating these unique IDs for all that. It makes no sense. Plus, you can easily do something else. Anytime you can do something sensible, you probably should instead of using UUID. But in this case, I actually think it makes sense. We have a fairly small number of palettes. Maybe it's going to be, 15 or 20 over a lifetime? Maybe 50? Maybe. So it's a small number. Why not use this UUID thing here? It's also really easy. Just say like ID equal UUID. And UUID is hashable, and so it can be an identifiable ID, all that business. Now I have some built-in palettes here, those ones that we saw in the demo. So I have a static called built-ins, and it's just an array of palettes. Right? Pretty cool. There's nothing special going on there. So that really is our model. A palette is a model. Now we're going to have an array of these things being our model, but this is the fundamental unit of our model. So now let's do our view model. Here, file new, file, Swift file. I'm going to call my view model my palette store. You'll often see view models called stores. When do I use the word store in the name of my view model? Well, when my view model stores something. And in this case, my view model for those little things at the bottom is going to store all those palettes. That's going to be its primary function. And we're also going to make this persist. Because one thing that's really annoying about our program right now is we create a beautiful emoji art, and then we go back and fix a bug, and we come back, it's all gone. And there's no persistence. Well, same thing is true with our palettes. We're going to be able to edit palettes, add new palettes, and then we run again, and they're all gone again. So we're going to make it persistent, and that persistence is going to live in our view model, in our palette store. We're not going to put that in our view somewhere. That's a great thing our view model can do, is provide persistence. And in fact, our view model for our emoji art document and for this will both provide this persistence for each of their views. So here's our palette store. All right, that's a good place for it right down there. It's in the UI because it is a view model. It's a class, we know that, called palette store. Of course, it's an observable object. We know that all by now. And we're going to say it's got one published var, which is the palettes, which is an array of palettes. That is our model for this view model, is an array of palettes there. Now, of course, it's complaining you didn't initialize your palettes. So let's go ahead and do that. Init. I'm actually going to have my palettes be named. You know, like I'm going to have my main palette, maybe a palette for my previews. Possibly I could even have named palettes where I'm using different palettes for different kind of emoji art projects or whatever. So I'm going to have it have a name. It's not super important that it's named, but I'm going to have it have a name. So let's go up here, let name string. And then so we'll have the init be init named this name. Then we can say self.name equals that name. And then the palettes, what are the palettes going to be equal to? Well, I'm going to start by having them be the built-ins, right? So that'll be our palettes. And since we don't have any persistence, it's just always going to be those. And yeah, we're going to learn how to delete them and bring them back and all that stuff. But it's just going to always reset every time we create a store for now until we put persistence in there. Now, here's a really interesting thing that I've done. I did not put private on that @published. I've spent this whole quarter talking about it, and I think you even asked earlier, like, why are you putting that private in there? Why are you always protecting your model? And I think, well, you don't always do that, and I'm not going to do it here, just to show you what it looks like not to do it, to have your view model offer the model up to the view directly. So my view is going to be able to do anything it wants to that array of palettes, delete things from it, add things to it, change things about it. It has completely free reign in there. Now, that is, you might say, why do I even need a view model if I'm going to do that? If I'm going to open up the model to just do whatever you want. The view model can still provide help to the view. For example, I'm going to have my view model enforce that there's always at least one palette. Because you can imagine as you're writing your UI code, if you have to deal with the case where you delete the last palette and now that's an empty view there, that might be some tricky code or some, and if then you have to put in there that you don't want to put in there. And it also makes no sense. You can't even do emoji art with no palettes. So I'm going to make it so that my view model says you can never have no palettes in here. So Mr. View, don't worry about that. So how am I going to do that? Well, one thing I'm going to have to do is right here in the init, I'm going to make sure that it starts out with at least one palette. So I'm going to say if the palette is empty, in other words, my built-ins didn't give me any, then I'm going to set my palettes equal to an array that has at least one palette in it. And let's just make something up, maybe warning. And the emojis, let's put a warning emoji in there. That'll be good. If I ever see this in my UI, I'll know, that's strange. There's a warning guy. And my users are reporting, hey, hello, I'm trying to do this emoji art and I'm getting a little warning thing and all my palettes are gone. Then at least you'll know, oh, oops, that hit that line of code, which it should never do because my built-ins should have kicked in there. But now I'm still possible to get to 0 palettes if the UI deletes the last one. I've given it free reign. How am I going to stop it from doing that? actually do something really kind of freaky here, which is in my did set for palettes, I'm going to say if the palettes are now empty and the old value of the palettes was not empty, then I'm going to set my palettes to the old value. That way I can't delete the last one because it's always going to keep reverting back. Now, you're setting your own var's value in its did set, you want to be careful here. Easy to make an infinite loop here. Now, I'm not going to have an infinite loop because I check to make sure my old value is not empty before I try to do this. But if I didn't check, it could just sit there looping forever, setting it to the old value, and they're both empty. So this is a little bit trickery, but for a demo, it's nice. It's really easy to enforce this. Now, another thing that my view model can do for the view is keep track of the fact that there's only one palette showing at any one time, right? I cycle through them, there's only one. So maybe the view model could provide a nice little published var here called cursor index or something like that, which will be an int that keeps track of that cursor. And why is that a help to the view? Because I'm going to make sure this is never out of bounds. And then my view will never have to worry about array index out of bounds. So I'm going to make cursor index there, that published var, never be out of bounds. The first thing I need is a little private function. I'm going to call it bounds checked palette index. It takes an index and it returns a bounds checked version of that. Now, how do we do that? Really easy. I'm just going to say, let's get the index modulo the count. So that makes sure that the index is in the counts space. But the index could be negative, so I better check for that too. If the index is less than 0, then I'm going to say index plus equals the palettes count. Then I'm going to return the index. So now I have a nice little function here that bounds checks the index, any index, into the palettes to make sure that it's there. And it's always going to work because we always have at least one palette. So at worst, this would come back 0. Everyone agree with that? All right, now how do I make this cursor index then be this protected thing? Well, I'm going to make this be private and be an underbar. And I'm going to have a public var called cursor index, which is an int, whose get value is to get the bounds checked version of the underbar private one. And for the setting, when you set the cursor index, I could just actually say underbar cursor index equals the new value. That's perfectly fine because anytime someone gets it, it's going to get bounds checked. But why not? Let's go ahead and bounds check it on the way in too. Bounds checked palette index, the new value. That way, if I ever looked at the inside of my code, it's not going to be some huge number or something like that. It'll be somewhere in the vicinity. So you can see my view model is still helping my view, even though it's given full access to it. And there's some other things you can do too, like I'm going to put these, I'm not going to type them all in, but here are some functions, insert and append, to add a palette to the palettes array, which the view could just do it directly. But if it uses these, then I'll make sure there's never two of them with the same identifiable, because I don't ever want that. So if you say insert one and there's one with the identifiable there, it'll just replace it in place. And if you say append to it and it's already in there, then it won't duplicate. So see, my view model can help. Even if it allows full access to the model, there's still things it can do. So let's go on to our view now that we have this nice, powerful, helpful view model and build that. So let's go here, new file. This is a view. This is going to be the view that represents the whole thing on the bottom with the button and the palettes. I'm going to call it palette chooser. That's what it does. Lets me choose the palette that I want. Here's our palette chooser. I'm going to put this a little higher up near the document view, just for fun. So what does our palette chooser look like? I'm going to, again, start with a little bit of like pseudo code, and then we'll flesh it out. This is kind of a good way to program too. If you can tolerate all the red errors happening while you do it, which can be distracting, it's still kind of a good way to do it. So I know that my palette chooser on the bottom, it's an H stack of that button, and then like a view that draws each of the palettes, the thing that's rotating. So let's do that, an H stack, like that chooser button. I'll call it chooser. It's going to be my chooser button. And then there's a view for what? For our store. Let's assume we have a variable store or something, the palettes. So I want to get those palettes. And what index do I want? I want that cursor index. How about this line of code? All right, lots of errors, but you get pseudocode. What I'm talking about here is like I want to have a palette store. That's going to be my view model. I'm going to go look directly at the model, and the index I'm going to get is that cursor index that the store is managing for me. And since I know it can never be out of bounds, and I know this can never return an empty view, this makes my code really easy like this. And so now I do need to obviously have these two things, a var called chooser, which is some view, and that's just going to be a button, that button that chooses it, and we'll have its label be an image, system image. And I think paint palette is the one I was using there. Paint palette is the name of the system image that does that. And then I had a func view for palette. That's just a palette of some sort, and that's some view. And so I have to have some view down here for that. And that I can even stub out too. That's an H stack as well with the palette's name. And actually a scrolling emojis view. Remember that scrolling emojis view that we had originally, where the emojis are the palette's emojis? So that's not even a stub out. Actually, I think that will just work as types. That's pretty easy. So let's go back up here and fix some things. Your button with only 2 T's instead of 3. This is all working. Problem is our store. Well, our store is our view model. We know how to do that, right? @observed object var store, which is a palette store. All right, we have no compile errors, so hopefully we have a working palette chooser here. And where are we going to use this? Well, it's going to replace that scrolling emojis that we have back in our emoji art document view. So I'm literally going to put it right in place here. I'm just going to say palette chooser instead of the scrolling emojis. I'm going to keep all the other things, the font size, the padding, hiding the scroll indicators. I don't need my emojis up here. But this is where you can start to see the problem. Look, missing argument for parameter store. Who makes this store? Is it state object here? For sure not, because this is an emoji art document view. And imagine we're in the multi-document situation on our Mac. We want the palette to be the same on all the windows. So definitely the palette store cannot be owned by the individual document views. It has to be up at the very top, shared out through our entire app. So we really want to put it up here in our emoji art app as an @state object. I'll call this my palette store because this is going to be the palette store for my entire app. And we'll call its name main. This isn't our main program. This is our main palette store. Now, I want to pass this palette store to my palette chooser. So am I going to pass it to this guy first and then he passes it along? That's pretty annoying to have to pass it through like that. Plus, my palette store is used everywhere in my app. You see what I mean? All my documents are all using this palette store, same palette store. So that if I were to add a palette down in this window, it would show up in the other window and I could start using it there. So how do I pass it in here? Well, now we're going to learn another @ thing to pass essentially state objects deep into view hierarchies. We're basically going to inject it right into the entire thing. We do that by saying .environment object my palette store. Doing this says there is this object, palette store, and it is injected to all views. If any view wants to use this, all they have to do is go like this. In my palette chooser here, instead of saying observed object and have it passed to me, instead I'm going to say environment object. By the way, not environment. That's a different thing we're going to learn about next week. It's environment object. So environment object says, get a thing of type palette store that was injected into me. Now notice that I can only have one palette store be injected in because there's no way to say which one, right? So this injection thing only works when you have one thing of a certain type that's injected down into a view hierarchy. Now another thing to think about here is that what about our previews? If I go back here to my preview, down here, my Emoji Art document preview, it has to do environment object and create a palette store here. So I'll just do palette store named preview for this one. Because remember, these previews, they don't get created from emojiart.app, okay, the main program. They're little previews that are running right there in Xcode. So you have to inject your own thing in, and you're also going to have to inject it not only here, its preview as well. Has to inject it in there. We'll use the same palette store, the preview one here. So environment object, really great for this kind of thing where it's kind of used globally. It's also great if you have some piece of some view model that you create at some level in a view hierarchy, and then everyone below it uses it. It's just like commonly used by everyone below. Well, you could have it be an @sign state object of this level, and then environment object inject it down. I'm going to do one thing, which is this scrolling emojis thing right here. I'm going to move that over to palette chooser. I'm not going to change it or touch it, but it's clearly part of my palette chooser, not part of my emoji art document view. So just a little code cleanup right there. Let's run this and see what happens. Oh, it's looking pretty good. I see it right there, vehicles. Let's cycle through them. Oh, it's not doing anything. Why is that not doing anything? Well, here is our button that does something, and it's not doing anything. So what are we going to do here? Well, we just want to go to the next cursor of our palette store, right? So this is a one-liner, store.cursorIndex plus equals 1. And again, you can see the value of our view model being so powerful here. It's making sure that bounds checked. We know it's always going to result in something that's valid. One-liner. Woo, it's working. No, not quite as nice. It's not animated. So let's put some animation in. Ooh, yeah, smooth. But again, not what we want. We want it to look like it's rolling. Remember that? How can we do rolling? Well, you know what? There's actually a really cool way to do rolling with transitions. If you remember transitions, one of the transitions is have this slide up from the bottom. Another one is have it slide up from the top. Well, if I have these things arrive by sliding from the bottom and leave by leaving up the top, it'll look like it's rolling. Now, I can do that. It's easy to go here and put a transition on this thing, dot transition. It's asymmetric because the rolling in and the rolling out are different. The insertion is move from the bottom, and the removal is move out to the top. So that's a reasonable asymmetric transition. That's not going to work, though. We try it. It was a good idea, but no, it's still opacity. It's still doing the default animation there. Can anyone tell me why this transition's not working? What do transitions animate? The coming and goings of views, right? Well, this H stack is never coming and going. It's just that this palette name emojis are changing. So it's just changing the name, this text and scrolling emojis, it's staying there. Well, its arguments are changing, but it's not causing the whole view. There's no for each or if else that's causing it to be removed. However, I'm going to show you a really cool feature to make that view get removed and replaced with another one. And that is to give it an ID. You just say .id and give it a unique ID. In this case, I can use my palette's ID. That will unique identify it. That makes it so that now this HStack, its identity is part of who it is. So when this palette comes in and it's a new one with a different ID, that whole view has to be replaced. right? Because it's a different view, because its identity, one of the aspects of it is different. So it's a different identity, and it'll replace the entire view. So ID is a really cool way to make views come and go by giving them identities. We run. Here we go. Woo! Working great, except this is kind of like our flying number thing where it flew up and then it just disappeared. You know, we had the flying number fade out, but that's no good. What we really want here is when it goes up, we don't want it to show. We want it to kind of get cut off here as it rolls up. No problem. We're going to go back up here and have this view be clipped. Remember, I told you that views will just draw right outside their bounds all the time, like our background does. We can stop that by saying clipped. If you say clipped, it stays inside its bounds. So now that I'm clipping to this H stack right here, when I roll up, it stays in its bounds, both on the bottom and the top as it comes in and as it goes out the top. Pretty cool. All right, only one other thing to do. Remember, when I press and hold, I had that thing where I could create a new one or delete. That's super easy to do. We're just going to go to our button. Here's our button right here. Actually, before I do that, I'm going to one quick thing. You see this kind of button that has a label? In this app, I'm going to create a bunch of buttons that have animated actions like this. Some of them have images on them. Some of them have text, etc. So in my extensions, I created a nice little struct here called animated action button, and it takes a title or an image and an action, and it just makes it into a nice button. This is purely done to make my code a little tighter, look a little nicer, not have so many curly braces and all that stuff. It just tightens it up a little bit. One thing to notice here, which I didn't talk about when we did aspect vgrid, and I meant to, is this action argument. You can see this is my init for my button, and it's taking the title and a system image, which are optional because you don't have to provide them. And this role is just whether it's a destructive button, like it destroy something, delete or something. And then there's the action. And notice it has @ escaping. We never talked about @ escaping. What does that mean? It means that this function, this init, is going to hold on to that closure and call it later. So it escapes from this init. And why does Swift want to know that clearly? Is because it's going to inline closures that can't escape. It inlines them, whereas in this case, it has to put it, closures are actually reference types. It puts them in the heap and gives a pointer to them essentially so they can be held onto. So that's what @ escaping is. And usually Swift can detect that, and it'll force you to put it there so that you recognize that that's what's happening. All right, so I'm going to use my animated action button here in my chooser. Instead of this thing right here, I'm just going to say animated action button. And this one's a system image with this paint palette. And this is the action. And since it's an animated action button, I don't need the with animation. See how that cleaned up my code right there? It's the same exact thing. It's just a cleaned up version of it. And what I'm going to do, though, is add a context menu to this animated action button. And context menu is just a view that's going to appear there. And it's supposed to be fairly structured. It wants it to be buttons, essentially. And you'll see that it's going to organize them in a certain way. And my animated action buttons are great for being in here. So I'm going to put an animated action button to create a new one, which has both a title and an image, the plus button for new. And this is easy to create a new one. I'm just going to use that nice insert I told you that my view model had. And inserts, well, eventually we're going to insert a new one that you put in the name and all the emojis, but here I'm going to make one up. I'll call it this is the math one I was showing you there. And emojis will be a bunch of math emojis. If we go down to math symbols, plus sign, minus, times, divide, infinity, whatever. Got those in there. And then I'm going to have another animated action button. This one is delete, and it has a system image as well. This is the minus in a circle image. And it's going to go right to the model it to the palettes and just say remove at the stores cursor. Again, you can see how our view model makes this code so easy. And if that was trying to remove the last palette, the view model would prevent that. It just wouldn't do it. See this in action? Ready? Click, working good. Press and hold. Delete, new. So we say new, there it is. Added it in the middle of our list there. And if we want to get rid of something, delete. Now delete is actually a destructive action. So I'm going to add to my delete this role, which is .destructive. I put it in the wrong place probably. Nope, still not right. There we go. Role was at the end. All right, so I put this destructive role in here. It's just an argument to button that says whether button's role is destructive. We go here, and we see it's red. Delete is destructive. You can also see that this view right here that the button is using as its title, this is called a label. A label is a special view that has a title and an image, and it knows how to format it properly depending on the context it's in, like this, a context menu. All right, we're out of time. So to make your assignment 5 even easier, I added some functions to move and resize your emojis to the view model. So you won't even have to figure that out. One thing I do want you to look at and note there is how I implemented that in the model, because I use subscripting. I made it so you can say emoji art subscript emoji dot size equals something, which is really convenient syntax. It almost looks like I'm accessing an array, but I'm accessing the emoji art instead, and the index is not an int, it's an emoji that's in there. And using that kind of subscripting can make for really clean code, as you will see. So take a look at that. You'll get all that when you clone your assignment 5. When you clone your assignment 5, it's going to have all the things we just did here, and also just some functions there for moving and resizing your emojis to make your assignment a little easier.